Okay, so we're going to work on cyclic hydrocarbons. That's where we should be at. Let me just turn this. Okay. So same thing. You always have to identify your shortest chain. I've lost my pen. Par for the course. And then after that, we still have the same pecking order. Okay. Have to identify the root. So how many cyclic means that it's attached. Okay. There's no, all the other ones that we've looked at so far are straight chain. Now we're looking at cyclic ones. So you still have to be able to count the number of carbons. So like in this example, 1, 2, 3, 4, 5, 6. So there's 6 carbons. And then you need to put in the word cyclo. So before we've had, like say, if this was a straight chain, we would have called this hexane. Now we're going to call it cyclohexane. We just put the word cyclo in front of it, and then we know that it's all joined together. We need to identify the type of bond. So it's exactly the same thing, right? The number of carbons, the type of bonds, and then if there's any additions to it. If we had a bond here, it would change from a hexane, cyclohexane, to a cyclohexene. If it was a triple, well, we can't. 1, 2, 3. Can we triple bond on a cyclo? 1, 2, 3, 4. Yeah, triple bond it. Although this would be incredibly unstable, you would have an ine. Okay. So the pecking order goes bonds, alcohols first. Second is halides. And then third is alkyl groups, like your methyl, your ethyl, those kinds of groups. Okay. So same thing. Again, numbering starts with the shortest way to the bond or to the alcohol, and then to the halide, and then to the alkyl group. So if we look at this example here, we see we do it orderly. We see we have 1, 2, 3, 4, 5 hydrocarbons. We see that there's a double bond in here, and we see that there's a methyl group in here. Okay. So shortest way to the double bond, because the double bond trumps, it starts at number 1, and we know that it's going to go from 1 to 2, and you just keep numbering around the circle in that pathway. So 1 down to 2, across to 3, up to 4, and over to 5. And so when we go to name this guy, our alkyl group is on carbon 4. So 4 methyl. This is a circle chain, so cyclo. It's 5 is pent, and it has a double bond, ene. And we don't put the 1 in there because on a cyclical hydrocarbon, it's always going to start at that point because it's the top. In numbering, you always start at the double bond. We don't have to put the 1 ene in there. If we look at this example, we have a carbon here, 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 and here. It's kind of confusing, but it kind of looks like it's in a circle. This is a really crappy drawing, but this part here, that's what's attached. See if I can do it. another color maybe that shows better. So this is the this is the cyclical part here. 1, 2, 3, 4, 5, 6. Okay, there's a group here, and there's a group here off the side. This is a very crappy photocopy. So a 6-carbon, a 6-carbon ring. We have a methyl group, and we have an ethyl group. Okay, and so we're going to go, wait for the computer to smarten up. We're going to go here, and we can start numbering. It's the shortest pathway to the first hydrocarbon. So because we go alphabetically, let's start with this being carbon 1. I really wish this was it. I'm just going to do it like this. Okay, that's essentially what we're looking at. Oh, I got this on the wrong guy. That's essentially what this picture is this here. And so we can see that there's an ethyl group here and a methyl group here. 6 carbons means that it's hexane. It's in a circle, so we're going to put cyclo in front. And then we're just going to start numbering 1, and then we go the shortest path around to the next group. We don't go 1 and then 2, 3, 4, 5. We go 1, 2, 3. We go the shortest way between the chains. So 1, 2, 3, 4, 5, 6. So it's 1 ethyl, 3 methyl, cyclohexane. Okay, that's a really poor drawing. Make sense? All right. Oops. Number 3 looks like this. Number 3 looks like this. Oh, I hate drawing these guys. It's an octagon. Okay. So first we need to identify all of the carbons. When we have 8, it's what? We have, what do we have here? A triple bond, so it's an ine. And then we have a group here, a group here, and a group here, because there's a carbon there, there, and there. So this group up top here we would call an ethyl, and these guys here, methyl. Okay, so we know that we have octine because there's a triple bond in there. It's in a circle shape, it's attached, so it's cyclo. And then we need to do our thing. So we're going to start numbering here. 1, 2, 3, 4, 5, 6, 7, 8. We don't go the other way around. We don't go 1 on the right side and then 2 on the second, because then it's so long to get to the next hydrocarbon chain. Okay, shortest path. So we're going to have alphabetically now, we're going to have 5-ethyl, 3,4-dimethyl cyclooctane. Okay. This one here first step, we have to identify how many carbons we have. 2, 3, 4, 5, 6. So it's 6 carbons in a ring, no double bonds, so it's going to end in an ane. That's the first step. Then we need to identify all of our side groups. There's one here, and one here. What takes precedence? Bonds and alcohols first, and then halides. So we're going to start here. We're going to go 1, 2, 3, 4, 5, 6. And the reason we went clockwise is because the next branch from 1 is closest this way, as opposed to going counterclockwise. And then this is a methyl group. So we know we have cyclohexane because it's 6 carbons in a ring and it's got single bonds only. Then we're going to start with our halides. So we've got 1, 2 dibromo, 4 methyl cyclohexane. And then when we work backwards, it's the same piece. Oh, you can see mine came through. We just have to unpack it. So this piece here, cyclo means it's a ring. Pent means it's 5 carbons. And it's got an alcohol group on it. And then on 2 and 4, we have a methyl group. So let's draw a pentane ring, which is just the pentagon. So 5 carbons. And we're going to start with the alcohol group because bonds and alcohols trump. And then from there, we're going to go to number 2 carbon and the number 4 carbon, and we're going to put a methyl group. And it doesn't matter if you go clockwise or counterclockwise. This here, I could have done this 2 and 4. It's the same thing. So wherever you start from the alcohol, the next carbon beside it, left or right, will be your methyl group. Okay? So let's pause here. Okay, let's work on these practice problems 559, 18 to 21. Let's look at number 18. So 18 says, name each of the following cyclic hydrocarbons. We have this shape here. There we go. And so what's the amount of carbons that we have in our circle? 4. 3, 4. 4 carbons in a ring. And we have a methyl group off to the side. So 4 carbons is bute. There is only single bond, so it's going to end in an ane. So we know we've got butane. It's in a circle. It's cyclo. And we're going to start here on 1 because that's the shortest route to that one. So we've got methyl cyclobutane. We don't need to put the 1 in because it obviously is going to start there. Okay, next one is Okay, so 18B, let's start with what we know when we look at our cyclical structure. How many carbons are there? 5. It's in a ring. Are there any single, double, or triple bonds? So they're single, so it's ANE. We have a side chain there, and we have a side chain here. This is an ethyl group. This is a methyl group. So we're going to just do it alphabetically. 1, 2, 3, 4, 5. So 5 carbon ring, single bonds. Cyclopentane. And then we're going to go 1 ethyl, 3 methyl, cyclopentane. Good? All right. Now we got to draw the condensed structural formula. So condensed is when you have like CH3, CH2. And so the first one is methyl cyclopentane. So pent is 5 carbons, ane is single bonds, cyclo means it's a ring, methyl means an alkyl side chain. This is what I do when I have to draw a condensed structural formula. Draw out my pentane in a ring, and I'm going to write into here. I'm just going to put my 1 here just because I have no space up the top. What you need to pay attention to is the amount of hydrogens change. So this particular carbon here is going to be CH. This one will be CH3. This one will be CH2, 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 and this one is going to be CH2. Okay? 1, 2, 3, and the hydrogen makes 4. Okay, next one. 1, 2, dimethyl cyclobutane. Bute means 4, ane means single bonds, cyclo means dimethyl means there's 2 alkyl groups. So butane, 1, 2, 3, 4. Off of 1, we're going to have a methyl group. Off of 2, we're going to have a methyl group. I'm going to put a carbon in each one of these spots. So this has got 1, 2, 3 bonds, so there's going to be an H there. This is going to be H3. This one here has 1, 2, 3, so there's only going to be one H. This one here will be H3. This carbon has 2 bonds, so it's H2. And this one here is going to be H2 as well. Okay. Rock solid. Question 20 says, name each of the following cyclic hydrocarbons. I really suck at drawing octagons. There's a double bond there. I'm just going to draw dots in where my carbons are. Okay, 28. So we got to identify how many hydrocarbons there are. Eight. It's in a ring structure. What kind of bond is in there? A double, so it's going to end in an ene. So I got cyclooctene happening. The double bond, we're going to go the shortest way to this methyl group. So we can go 1, 2, 3, 4, 5, 6, 7, 8. If we start the double bond on this side, we would go 1, 2, 3, 4, 5, 6, 7. So the shortest way is to go this way. So we have 4-methyl cyclooctene. And the next example, okay, so I cheated. In your book, it's condensed structural. So our carbon, our main carbon is 5 in a ring with what kind of double bond? Or what kind of double bond? Oh my goodness. So we know that we've got cyclopentene. And then we got a methyl group here. And over here, we have what kind of group? One, two, three. Propyl. Shortest way, including the chain to the first group, M comes before P, so we're going to go 1, 2, 3, 4, 5. So we're going to have 3-methyl, 5-propyl cyclopentene. #21. Draw a condensed structural formula for each compound. 3-methyl cyclopentene. Okay. Pent is 5. Ene is this is a ring structure, and it's got a methyl group, alkyl side chain. So we're going to draw pent. We're going to put a double bond in, and from there we're going to, at 3, so 1, 2, 3, we're going to put a methyl group. Does it matter where you put your double bond? No, you just need to go 1, 2, and then the next carbon will be 3. It can be any position around that. Okay, last one. We got 2-ethyl, 3-propyl cyclobutene. Okay, working backwards, but is 4, ene is, cyclo is a ring, and then here's 2 side chains, 2 alkyl groups. So 4, 1, 2, 3, 4. It's asking for condensed, so I'll put carbons in. There's a double bond, and then on 2, so 1, 2, there's an ethyl group, and then on 3 there is a propyl group. So now when we go through and we look at hydrogens, because that's why they're asking you to do the condensed structural formula, is to pay attention to the number of bonds you have around a carbon. This carbon here already has 4 bonds, 1, 2, 3, 4. This one has 2, so it needs 2 hydrogens. This one needs 3. This one here has 1, 2, 3 bonds, so it needs a hydrogen. This one here has 2 bonds, so it needs 2 hydrogens. And this one in the top left needs 3. 1, 2, 3, so it gets 1 hydrogen. Does yours look like that? Perfect. You rock. Okay, aromatic hydrocarbons are simply an extension of a cyclic hydrocarbon, only it has the maximum number of double bonds that you can have. So an aromatic hydrocarbon is always a benzene ring. And it's unsaturated because there is not the maximum amount of hydrocarbons that you can have around it. Benzene ring is a 6-carbon ring with 1 hydrogen atom bonded to each carbon, and the double bonds alternate. So you can see here there's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, but you alternate. We couldn't do 2 bonds like this. It doesn't work side by each. This is key here, that aromatics imply that these aromas or aromatics have strong smells. They're what we get our scents from. There are quite a few ways to draw this. Three down one side, so you can go double bond, skip, and then a double bond. Or you could go the other way. Either or, they're the same thing. Or, and this is the lazy chemist way of doing it, just draw a circle, which means that all of those things are double bonded to their abilities. So here's how we differentiate between an aromatic and a non-aromatic. An aromatic has all the maximum number of double bonds it can have. An aliphatic hydrocarbon is not a benzene ring. So alkanes, alkenes, alkynes, and cyclic hydrocarbons, they're aliphatic. Anything else would be an aromatic. Okay, so now we're looking at 2 different classifications of hydrocarbons. There's some special rules with aromatic hydrocarbons. If the molecule contains a benzene ring, we end it off with benzene. And so you're going to be looking for the 6 carbons in the benzene ring, and then you go to the side group. When a benzene group is a side group, so this is really important because this does happen. When a carbon chain is more than 7 carbons long, and then there's a benzene group attached to it, it gets called a phenyl group. It actually becomes the side chain and not the main chain. Okay, let's look at this example here. Oh, I can't see. Okay, we can see the traditional benzene ring. So we have a benzene. And then we have 2 side groups. And these side groups, there's 1, 2, 3. And in here, there's 1, 2. they're not more than 7 carbons long, so they are side groups. 2 carbons is an ethyl group, 3 carbons is a propyl group, and so we're just going to start numbering it. E comes before P. 1, 2, 3, 4, 5, 6. So you're going to have 1 ethyl, 3 propyl, benzene. Make sense? Okay. Example number 2 looks like this guy here. And here. So this is what we're talking about. This benzene ring is 6 carbons. And this supposed side chain isn't like a butyl group on this side and an ethyl group on this side. It's actually 1, 2, 3, 4, 5, 6, 7 carbons long. So then the benzene ring actually becomes the side chain, and it gets called phenyl. Okay? So there's 7 carbons long. What type of bond? Single. And then we have a phenyl group. So it's phenyl. Oops, gotta tell it where it is. 3-phenyl. There's no dash there. Heptane. Ooh. Drawing it's far easier. Benzene ring tells you that it's the main chain, that there's 2 methyl groups here, and there's an ethyl group here. So when we draw it out, whoops, on 1 we have a methyl group, 2 we have an ethyl group, and 4, 1, 2, 3, 4 we have a methyl group. The second one, we see the word phenyl. This means that our benzene ring is actually the side chain. And this is our main chain here. It happens to be 8 carbons and a single bond. So 2, 3, 4, 5, 6, 7, 8. And on number 2, there's a phenyl group. Now, this phenyl group could be on this carbon over here, because that's also 2 in. Okay? Now let's look at page 562. 60. I want this to be all in order, Mrs. Pyre. Do you have a 562? Oh, I'm making this way harder than it should be then. Okay, so we're going to look at 562, number 24. It says name the following compound. We gotta wait for the smart board to smarten up. So this is what A looks like. Clearly there isn't more than 7 carbons in these two side chains, so we've got a benzene group. And then we've got this side chain here and this side chain here, which both happen to be ethyl groups. Next one looks like this. Okay, so B. Again, we see that our two side chains don't have more than 7 hydrocarbons in it. So these are side chains. This is going to be our main chain, so benzene. Oh, we didn't finish naming the first one. They're both ethyls. 1, 2, 3. So 1, 3 dimethyl, diethyl benzene. This one here, we have a methyl group, and 3 carbons is prop. Okay, M comes before P. So we're going to start here. 1, 2, 3, 4, 5, 6. So we're going to have 1 methyl, 4 propyl benzene. Then C looks like this guy. So when we look which way it's going, we see that this set of carbons here is 7 carbons long, which means that this benzene ring now becomes a side chain, and it's a phenyl group. So 7 carbons long, any double, single, double, or triple bonds? They're all singles, so they're ane, so it's heptane. And we're going to go the shortest route to the phenyl group. 1, 2, 3. So it's 3 phenyl heptane. Whew, that was the example. That's totally not what we were supposed to be doing. Awesome. 24. Well, I'm moving right along. Whoops. Here we go. First step. Benzene ring. Second step. And they are all what? Methyls. And then we just got a number. So this would be 1, 3, 5. Trimethyl. Trimethylbenzene. Perfect. That's 24. 25. Draw a condensed structural formula for each 1-ethyl 3-methyl benzene. Benzene means that this is the main attraction. On 1 we have an ethyl group, and on 3 we have a methyl group. Condensed means that this is CH2, CH3, 3, CH3. These are just carbons. Oh, this is CH. 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 That one's got 4 bonds on it. This is a CH. The other one is 2-ethyl 1,4-dimethyl benzene. Benzene is the main show. And so on 1, there's a methyl group. On 2, there's an ethyl group. And on 4, there's a methyl group. So that's 4 bonds. That's just a carbon. This will be CH. That's 4 bonds. This is CH. And that's 1, 2, 3, 4. That's just a carbon. And then what's to do number 26? Draw a structural formula for 2-phenyloctane. So this here means 8 carbons, single bonds. This is the side group. Okay, the phenyl. 2, 3, 4, 5, 6, 7, 8. And on number 2, there's a phenyl group. Actually, it's structural, so it goes like this. Get yours to look like that? I know, it's a pain. Name the following aromatic compound. 2, 3, 4, 5, 6, 7, 8, 9. Okay, when we look at these 2 benzene groups, we see that this row of carbons is greater than 7 carbons long. So it's going to be nonane because there's no double bonds in there. And then it's going to be 2,3-diphenyl. Perfect. So let's stop there because this next stuff is really super complicated. It's not super complicated. It's just a lot. We're already at 44 minutes. It's plenty of learning.